implies this kind root than having sets on the back of it. So Quine, of course, would not take the universalist account here that Vernon would take. But yeah. I'm not an expert on Quine's view on this, so maybe I shouldn't say too much more about it. Okay. Let's look at the emergence option then. So I think that this is a slightly more promising version of what I presume is a realist theory about natural kinds, because there would be something generally non-reducible in the kind. Whatever the kind is constituted from, the natural properties or what have you, the kind itself would be something more than its parts. You can't have a full reduction of the kind to its parts, and you could see this in a way that the kind itself might be able to survive the change in some of its parts. Maybe it's difficult to find uncontroversial examples, but you might think of the gold atom, since I'll be using that as an example. It has a number of electrons. Well, maybe you could change one of the electrons into another electron, but it would still be a gold atom as long as it's got the same number of these electrons. So the kind might survive the change of some of its parts in this sense, and be more than just the parts. Maybe you can identify the kind then with the causal powers in question, so the mechanism comes into it as well, and that's why I think that this might be a version, or Boyd's theory might be a version of this type of theory. That's controversial though. Not everyone would like to think of this in the same way. But in this view, the cluster of these properties, these natural properties coming together, would not be accidental. There would be this mechanism that's responsible for it. Okay, well, I'm going through these quite quickly, but that's partly because I'm sympathetic to a version of the natural kind fundamentalism view myself. And I do have some reasons for it. That's because I don't think that the fundamental kinds, if you look at fundamental physics, they're really the best candidates for natural kinds that we have. I don't think that you can easily account for them in these other theories. So think of fermions, electrons, a type of fermion, or bosons. Well, they appear to be definable just with reference to one natural property. In this case, there's spin. So fermions are particles with half-integer spin, and bosons are particles with integer spin. Never mind the details, but if that's right, then they can't be complex universals. I recently actually discussed this with Alexander Bird, who favors this complex universals approach, and he didn't really have a theory about the fundamental kinds. But that seems wrong to me. That seems the wrong way to approach the topic, because if these fundamental kinds, if these fundamental physical objects are our best candidates for natural kinds, well then we better have some theory about how they get their kind root as it were. And indeed, if we want to address this challenge from Mill mentioned, we have to then distinguish the kinds from natural properties. So on this view, we would have to really and properly distinguish the properties from the kinds, and have a type of double primitive going on. Go ahead.
So the fundamentalism differs from the others in that it's a primitive, and so you could have, say, the kind fermion without there being any fermions, and you have uninstantiated.
Yes, in theory, yes. Although, of course, that brings with it a number of problems. So you could say that only the instantiated kinds are real kinds. But actually, I think I would personally want to bite the bullet there and say that you could have this kind without there being any instances of it.
You wonder how chemists, create new atoms, and it's not like they created the kind had to.
That's right. Yeah, that's right. We talked about this in class today as well. This exact example. So you can have good candidates for natural kinds, the highly radioactive elements that you don't have in nature, and we can even predict their chemical properties very accurately. But they don't occur naturally at all. It seems like the kind was there to be discovered, as it were, even though it didn't have any instances. We just created the instance. Also, if you take seriously this talk about possible worlds or alternative physics, you might think that there could be different kinds of layouts of natural kinds, and of course they wouldn't have any instances, at least not in the actual world. But let's not go into deep moral metaphysics right now. The point is that there's various ways to, I think, bite the bullets of that very challenge, which is quite right, and not lose one's head.
So just to note, so do you think there could be like a possible world with nothing but the kind fermion populating it and nothing else? Maybe there'd be one fermion and that kind.
Yeah, well, I suppose why not? I mean, it wouldn't be a very interesting world.
No, that's good. Well, I guess the reason I ask is if it's definable in terms of spin, I'm just thinking does spin require the existence of other objects in order to determine spin? So yeah, that's.
Yeah, well, you may be right. We'd have to look at the physics a bit more closely before making judgment about these scenarios. So, in fact, I'm sort of assuming that we're looking at what we might call intrinsic properties internal to the object of the kind here all the time. But some of these sort of important properties, they might be relational in an important sense. So that to have that property, you have to have another thing here, and you have to have another thing here. And without the two things, you don't have the property. Being someone's sibling doesn't really work if there's two people. Well, being a sibling probably isn't a fundamental, natural property. But it's not ruled out by the view by any means that there couldn't be such properties. And there are important views developed in modern social science and metaphysics that take the relational properties very seriously. So I don't want to rule that out. And indeed, that might rule out, if that view is true, that might rule out some of the scenarios we're interested in. But a very good point. Yeah, so primitives. I have this picture. You get your natural properties, natural kinds. This is at the level of fundamental categories, if this view would be correct. And you get the properties there, and you get your kinds here. And then the question is, how are they linked? Well, we could have the case that just one natural property defines the natural kind, if the story is correct. But we could also have a case where we need, say, 3 natural properties to define the kind. There's another case where we've got one property, one kind. And of course, we've got all these other natural properties that might not be linked to any kinds at all, like the whiteness property that we talked before. If whiteness is not in the natural kind group, it might still be here. And that's one reason why I like this double primitives picture. Of course, it brings with it some costs. You have to assume more stuff in the world. But I think that to get all the explanation that we want from natural kinds, we've got some reasons to favor this. And of course, you should note here that all the kinds here are linked to natural properties. So we don't have kinds here standing on their own. They must have their basis or some sort of link to the natural properties. So even if they're fundamental, they might have to be related to the kind science. Go ahead.
In that case, why wouldn't the natural properties be kinds themselves?
Well, it's a view that could be attempted. I've got some reasons that I'll get to later on why I don't think that that's an attractive view. But if it turns out that we can do all the as it were explanatory work that kinds are supposed to do by just assuming natural properties, well then that would be obviously a favorable view that we should favor. It'll turn out that I don't think that that's right, but that's a kind of view. And so far I don't think I've really said anything to rule that out. So, good point. I'll try to get back to this, but you can call me out on it if I don't answer this satisfactorily later on. Okay.
I'm noticing earth, air, fire, water over there on the left.
Oh yes. Okay, I'll get to the naturalist part. I'm taking a little more time than I thought, but never mind.
Good, thank you.
Yeah, well, I think there'll still be time for discussion. Okay. So, naturalist part. So, actually, this is just repeating what I've said already. So, even if you think that natural kinds are universals, complex or simple or otherwise, that doesn't fully account for the resemblance question. We have to give a fuller story here. But here's where some preconditions come in. So I don't think that for this sort of view to work about, to take natural kinds seriously, I don't think that you have to have a lot of them all over the world. I think that there could be very few natural kinds or natural properties. Really, all you need to be a natural kind realist is one natural property. And this is another thing that we talked a little bit about in class. The type of modism could be one version. So I'm not going to go into the details here, but there's a theory that assumes that the world could be described just by a universal wave function, and different aspects of the world could just be aspects of the universal wave function. Now, kind of a difficult view to get your head around, but if that view were to be correct, and if we take it seriously, well, on that view, it looks like there would just be one natural property, the universal wave function, and that's what the world is. Maybe this would be a version of the view that the world is just one simple natural kind, and all the divisions that we have there would have to be accounted for in some different ways. So a type of a monistic view, which has raised its head in recent literature. But I'm not going to go into more detail about that now. It's one possibility and an option that's out there. Now, to put some more physics in there, the entities that have these natural properties, I haven't talked about those at all. And we don't really need to, because they could be a number of things. Here's Barry Lower saying something, slightly different context. What the entities that possess these natural properties could be. Well, they could be points and regions of space themselves, classical point particles, Bornholm point particles, one-dimensional strings, two-dimensional grains, electromagnetic fields, wave function fields, blah, 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 and so on and so on. You don't have to care about that. The point is that they could be anything whatsoever. Whatever physics tells us that there's out in the world, that's the stuff that can possess these natural properties. Sounds like an easy way out, perhaps, but the point is to be as neutral as possible we can about this, so that we don't contradict the physics itself, basically. Okay, so we just need this one genuine property to get the view going. But of course, that wouldn't be a particularly interesting view, at least not if we want to do all this exciting work about it with natural kinds as we usually do. So, now we finally get to the business of defining naturalism. And now, I should say that when you see sparse in the literature, with reference to sparse properties, that's just a synonym for natural properties. I really don't know why there has to be two terms for this, but that seems to be the case. So it's good to be aware of it. So there isn't a lot of literature on how we are supposed to get our heads around natural properties, but there is one nice paper by Jonathan Schaffer called Two Conceptions of Sparse Properties, Two Conceptions of Natural Properties. So the two conceptions that he has are what he calls fundamental and scientific, and they're distinguished by these three criteria. Similarity, the properties should ground objective similarities. This is just a minor independence criterion, really. We don't need to go into that too much here. And causality, so the property should carve out causal powers. That's what we've been talking about as well, the causal profile and mechanistic discrimination. And they should serve as a minimal ontological base. Now that means that they should be at the fundamental level, it seems, at the fundamental physics level. Okay. Well, this view, so the fundamental view would just identify with the minimality. That's what I mentioned in the beginning. That's the view that only the perfectly joined common properties might have carve out the natural kinds as well. Chapman himself favors the view that, well, there's probably natural kinds, there's probably natural properties all over the place from all levels of science. So he thinks that we should drop this minimality criterion and take this, what he calls the scientific conception, which just fulfills these two criteria. So he says that the natural sparse properties are those invoked in the scientific understanding of the world. Well, that sounds good. We wanted to do science, that's where we get it. Problem is, he doesn't say very much about what the scientific conception or understanding of the world is supposed to amount to here. Protons, molecules, biological species perhaps, they seem to be in the scientific worldview, scientific world. What about psychology, economics, social sciences? Not clear. Money and mental illnesses. I've talked about money, talked about mental illnesses in all the class. Are they sparse or natural in this sense? Well, maybe they don't fit the bill in terms of the second criteria, causal influence of the world or the objectivity. But that's not clear. There's some recent literature that argues that at least some of these sort of what we might think of as social kinds do actually feature in various sort of causal laws and generalizations that we make. And some people argue that mental illnesses could be natural kinds as well. So even the mind independence criterion has actually been questioned recently. In a nice paper by Matthew Slater called Natural Kindness. So this is just to say that there's ways to keep question these things. Alidi says, as far as the kind properties are causally rather than conventionally linked, social kinds could be candidates for natural kinds. Go ahead.
A couple of slides back, just looking in terms of genuine properties, and you've been thinking around mind independence. So does this, all of this, incompatible with the Copenhagen observer-dependent interpretation of quantum mechanics? Whether it's a waiver or partial depends on how you look at it. And until you look at it, it's not either or it's both.
Yeah, well, I'm not sure if the right way to think about Copenhagen education is that there's no.
Well, it's one of the ways.
But it might be one of the ways. Yeah. So I think there's ways to get around the problem, even if it's totally vague in some cases, whether something's another thing or another thing. It doesn't mean that in some cases there wouldn't be a fact of the matter. So we did talk about this as well, actually, in class a little bit, but I'll put it briefly. I guess I'd like to think that even if there's vagueness in the world, metaphysical vagueness, right? We can still make classifications in some cases. There's going to be a clear case, a clear example of a kind here, and a clear example of a kind here, even if the borderline cases between them might be problematic. So we can point out to a man who's clearly bald and point out to a man who's clearly not bald, even if there's a variety of borderline cases here. Now, it's going to be a little trickier, of course, in the quantum case. So I'm not trying to wiggle my way out of this by just say that this is analogous. But I do think that there's ways to go here where we can salvage the idea that there being genuine classification or kinds in reality, even if they are always vague, even if all of them are vague, in fact. Although I find that that's an implausible position to be. But I don't know. Jessica Wilson has some interesting recent work on this, actually, which we can talk about it later.